on this number 5, yes, we're dividing by 2x minus 3. But look at the polynomial we're dividing up. It skips from x cubed down to x. When that happens, you insert a 0x squared. You put a 0 term in there for each term that you skip over in the descending pattern of the exponents. That's the trick in this problem. Now, when we start this division, 2x times what makes the 4x cubed? The answer is 2x squared. 2x squared on the top times each of the side gives us 4x cubed minus 6x squared. Notice how we've got a 0x squared to line that up under. Had we not had that, we would have lined it up under the 5x, and there was a chance we could have combined things that are uncombinable. We're now going to change the signs of this next row and add the opposites, which adding down gives us 6x squared plus the 5x I'm bringing down. We look at the 2x out front, we look at the 6x squared right there, we say multiply by 3x to go from one to the other. Notice up on top we have our descending order of exponents, which is good. Now we're going to take that 3x times each term on the side and multiply to get 6x squared minus 9x. We're going to add the opposite, changing that to a minus and a plus. The 6x squareds cancel out, but adding down in the next column we get 14x, bring down the minus 12. We then look at the 2x out front, the 14x right there, we get plus 7 up top. That 7 up top multiplies by both on the side, giving us 14x minus 21. We're going to add the opposite. Negative 12 plus 21 gives us a remainder of 9. So plus 9 over 2x minus 3. Now let's double check it with my little analysis I gave you. We take the minus 3, we multiply it by the 7 to get minus 21. That minus 21 plus the 9 does take us to the minus 12. So odds are we got it right if we checked when we checked that. Number 6, a little bit on the interesting side. Let me get that in focus there. Notice how we drop straight from x cubed down to the constant term. We skip over the x squared and the x. When we go to write our division problem out, we insert 0 terms there. X cubed plus no x squareds plus no x's, then finally the minus 27. So it's possible to have that. More zeros added in, and if it was an x to the 5th going all the way to a constant, we'd have more 0 terms put in there. Okay, let's finish this off. X times what makes x to the 3rd? The answer is x to the 2nd up top. X to the 2nd up top multiplied by each on the side gives us x to the 3rd minus 3x squared. Add the opposite, minus then plus. Adding down now, we have 3x squared, bring down our 0x. X out front, 3x squared right there, it goes in 3x times, so plus 3x on top. That 3x on top multiplied by both on the side gives us 3x to the 2nd minus 9x. Adding the opposite gives us a minus and then a plus. 0 plus 9 gives us 9x on the next row, minus the 27 that we bring down. X on the top left, 9x right there, it goes in 9 times, so plus 9 on top. 9 times the x minus 3 gives us 9x minus 27. And we add the opposite, minus and plus. This time we have a remainder of 0, which means the x minus 3 went in evenly. Evenly meaning without remainder. Okay, one last problem just to show you how to handle this situation. We're dividing by p squared plus 2, which will come out here on the left. Inside here we've got our p to the fourth minus p to the third minus 4p squared minus 2p minus 15. We're going to do exactly what we've been doing. P squared out front times what makes p to the fourth? Answer, p squared. When we multiply that p squared on top by both things on the side, we get p to the fourth plus 2p squared. Notice where that lined up. I did not put it under the p to the third because it didn't belong there. Because we skipped over a position here in our divisor, we're skipping over a position underneath here. We're going to add the opposite, changing these signs. The minus p to the third is going to just kind of fall through the cracks there because nothing is being subtracted. We're going to have minus 6p squared in the next column, and I'm going to bring down the minus 2p at the same time. We then go back to our questioning process. P squared times what makes that minus p to the third? The answer is up top, minus p. Negative p times both at the side gives us minus p to the third minus 2p. Notice where I lined that up under the other minus 2p. Adding down, or adding the opposite, that becomes a plus, that becomes a plus. We have negative 6p squared. The 2p's cancel altogether, so I'm going to bring down the minus 15. Over here at the left, p squared times what makes minus 6p squared? The answer is minus 6. Minus the 6 times both things at the left gives us negative 6p squared minus 12. Adding the opposites gives us a minus 3 remainder. I'm going to write that, however, as plus a negative 3 over the p squared plus 2. To do my quickie little check that I showed you a moment ago, we're going to take the 2 times that negative 6 makes negative 12, and negative 12 then adding this minus 3 remainder on takes us to the minus 15, and we're good to go. So that is how to handle long and just regular division. Remember, going back to the previous page, that if you are dividing by a monomial, to split this into two separate fractions, whereas if you aren't and you're dividing by a non-monomial, that's when you can use the long division.